All right, so we're going to continue the 3.2 video, and this one is going to be with elimination. So we're still solving the system of equations, but this time we're going to use another method, and that is elimination. So remember I said we've got to know the difference between substitution and elimination. So substitution, we were taking something and substituting it into one of the equations. For elimination, we're going to be eliminating something. So let's look at our steps. The first thing that we want to do is multiply one or possibly both of the equations by a constant, and they can be multiplied by different constants for each equation. But we're going to do that to obtain coefficients that differ only in sign for one of the variables. So what that means is that either your x's or your y's are going to need to have the same number, but opposite signs. So we want one of the variables to have the same number, but one is going to be positive and one is going to be negative. Because if I have the same number, but one's positive, one's negative, then they're going to cancel out. That's how we're going to eliminate one of the variables. So once we've done that, then we're going to add those revised equations from step one. And when we do, that variable that we got that has the same number but opposite signs should eliminate, because it will add together to give us 0. They sometimes call that a zero pair, because when you add them, it gives you 0. So combining like terms will eliminate one of the variables, because you will have a 0 pair. When it adds together, it gives you 0. So it goes away. And then if that one goes away, we will now only have one variable left, and we can solve for it very easily. Once we have the answer for one of the variables in step 2, then we move on to step 3, and we're going to take that value that we got in step 2, and we're going to substitute it into either one of the original equations. Once we do that, we'll be able to solve for the other variable, and then we'll have our x and our y, and we can write our coordinate point. Now, when we're setting up elimination, sometimes it's very nice, and they give us a system that we actually don't have to change the numbers. They have already given us a 0 pair, a variable that has the same number but opposite signs. And in example 4, they've done that. Because if I look at my x's, I have a positive 4 and a negative 4, which means those are already set up to cancel. That is a 0 pair, just the way it is. So I don't have to modify anything. I can go straight on to step 2, which is to combine the like terms or add the equations together. So when I take positive 4x and subtract 4x, then those are gone. Then if I take my y's, if I add 2y and 3y, then that gives me 5y. Then I have my equal sign, and I take 9 plus 16, and that gives me 25. And as you can see, we now only have one variable, and that's very easy to solve for that variable from there. So we're going to simply divide both sides by 5, and I'm going to get y equals 5, because 25 divided by 5 is 5. So I've got one of the variables. I just need the other one. So now I can take that value that I just got, and I can plug it into either one of my original equations. So I can either plug it in here for y, or I can plug it in here for y. And it doesn't matter which one. I'm going to take the first one because those are all positive numbers. So this was step 2 because step 1 was already done. So I'm now ready for step 3. So I'm going to take the first equation. So 4x plus 2y equals 9. And I'm going to take my 5, which is y, and I'm going to plug it in there for the y. So that gives me 4x plus 2 times 5, because y is 5, equals 9. Then I can simplify just a little bit. Then that's 4x plus 10 equals 9. And now I'm ready to start solving. So I'm going to first subtract the 10 because we know the 4 in front of the x is the last thing we get rid of. So those 10s are gone. So I have 4x equals -1. And then divide both sides by 4. And I have x equals, you can either leave it as -1/4, which does not simplify, or I would be okay if you had -0.25 if you put it in your calculator. That is fine as well. But either way, we've got the equation, or sorry, we've got a value for both x and y, which means we can write our answer as a coordinate point. So make sure you put it in the right order. Remember, x must come first. So x is our -1/4, or I'll let you get away with -0.25, just don't lose your negative. And then the y value is 5. And so then that is our answer. And again, just like in the other problems, we can check our answer. So if we go back to the original equations, if I plug in -1/4 here, I plug in 5 here, do the math, I should get 9. If I plug in -1/4 here and +5 here, do the math, I should get 16. All right, so then we've got 2 more of these and then a couple of special problems, and we'll be done. All right, so for number 5, what's the solution to the system of equations? So again, we're going to use elimination because this is the elimination section of the notes. So we want to look and see, first of all, do they have either of the variables already set up to cancel? If so, I get to skip step 1 and move on to step 2. If not, then I'll have to modify one or possibly both of the equations. So if I look, x, that's not ready to cancel. I've got a -2 and a +5. However, my y's, I have a +8 and a -8, which means that's a 0 pair. They're going to cancel out. So step 1 is already done. Then step 2 is going to be to just combine our equations, add those like terms. So for this one, I have -2x and a +5x. So -2 plus 5 is a +3x. Then I do my y's, so +8 and -8 cancel out. That's a 0 pair, they're gone. And then I have -8 plus 20, so that gives me a +12. Then all I have left is x, so I'm ready to divide and get the answer for that. So divide by what's in front of x, which is 3, and I get x equals 4. So there's half of my answer right there. Now I need to get the y value. So I'm going to go back up and use one of my equations. It does not matter which one. I'm going to go ahead and just take the top one again. No particular reason, just because you can choose either. So then if I use my top equation, -2x, x, plus 8y equals -8. And then I plug 4 in for x. So that's -2 times 4 plus 8y equals -8. All right, so I have -2 times 4. That's a -8. Then I have my plus 8y equals -8. All right, I know that this 8 is the last thing I get rid of. So that means this 8 is the first thing I get rid of. So to get rid of that -8, I'm going to add 8, which means I have to add 8 on the other side. Now, these 8's cancel. That's great. I'm left with positive 8y, but then something unexpected happens. These 8's also cancel. So -8 plus 8 is what we call a 0 pair because it adds together to give me 0. And that's okay. We can do math with 0. We can add anything to 0. We can subtract from 0. We can multiply by 0. We can divide by 0. We still get 0, but we can do it. So then just keep following the math. We know we want to get y by itself, which means we need to get rid of that 8. So we would divide by 8, divide by 8. And so we have y equals, then 0 divided by anything is 0. So it is fine to have a coordinate of 0. There's no problem there. So our answer then, remember, x must come first, and x was 4. Then we have y, which was 0. And so that means if you were to graph those lines, they would cross at 4, 0. So that's our answer. Again, you can plug 4 in for your x, 0 in for your y, and it should equal negative 8 in the first equation, and it should equal positive 20 in the second equation. All right, so then let's do one more of these, and then we'll look at a couple special cases. All right, now for this one, the solution of the system of equations, we're going to have to do a little bit more work here, because if we look at the x's, we've got 3 and 5, those won't cancel. If we look at the y's, we've got 7 and 2, those won't cancel. So I need for either the x's or the y's to cancel. So if they're not ready to cancel, I need to figure out what can I do to get them to have the same number but opposite signs. Now the only thing I can do to modify is to multiply. So I'm actually going to end up multiplying both equations. Now, I can choose to either get the 3 and the 5 to be the same number, or I can choose to get the 7 and the 2 to be the same number. Doesn't really matter that much which one. I think I'm just going to go with the x's. So if I want 3 and 5 to become the same number, I need to think. All I can do is multiply. So what can I multiply and get 3 and 5 to be the same thing? Well, I can multiply 3 to become 15, and I can multiply 5 to become 15. So I want to get those both to be 15, but remember, one has to be positive and one has to be negative. So in order to multiply 3 to get 15, I'm going to multiply it by 5. In order to get 5 to be 15, I need to multiply it by 3. Now, if I leave it the way it is right now, I'm going to get a positive 15 and a positive 15, and I don't want them both positive. I need one of them to be negative. So I can either say, okay, let me multiply by a negative 5. That'll give me one positive, one negative. Or I can make the 3 a negative. That's still going to give me one positive 15 and one negative 15. So either way is fine. I'm just going to leave it on the bottom one. Now, when I multiply, I have to make sure that I multiply by everything in this equation. Everything, including what's on the other side of the equal sign. So if I start with 5 times 3x, that gives me 15x. Then I do 5 times 7y, that gives me a positive 35y, equals 5 times 15, that should be 75. All right, so the first equation is modified. Now I need to do the second equation. So when I multiply by a negative 3, so negative 3 times 5x gives me a negative 15x. Negative 3 times positive 2y gives me a negative 6y, equals negative 3 times negative 4 gives me a positive 12. So now, because I have this 0 pair, those are now ready to cancel, we call it a 0 pair, then I can go ahead and combine my equations. My 15x's are gone, and then I can combine the y's. So if I do 35 minus 6, that's going to give me 29y, and then equals 75 plus 12 should give me 87. Then to solve, I need to divide by 29. So then if I grab my calculator and I do 87 divided by 29, what do you know? That comes out to a nice, neat, even 3. So y is 3. So step 1 was multiplying by the 5 and the negative 3. Step 2 was adding the equations together once we have that 0 pair. Now we're ready for step 3, which is to take that value for y that we just got, 3, and plug it into one of the original equations. Again, I'm just going to take the top one. I don't have a reason, I just am. So 3x plus 7y equals 15. Now remember, this 3 is y. So I need to take it and I need to plug it in here for y. So that gives me 3x plus 7 times 3 equals 15. So then 3x plus 21 equals 15. Now I can start solving. I'm going to subtract the 21 first, and 15 minus 21 is negative 6. So that gives me 3x equals negative 6. Then I can finally divide by that 3 that's in front of the x, and I get x equals negative 2. So I have an x value, I have a y value, which means I'm done. So my answer is x, which is negative 2, comma y, which is 3. And again, you can plug in those values to both of your equations, and it should simplify to 15 in the first equation. It should simplify to negative 4 in the second equation. Alrighty, now we've got 2 special cases that we're going to talk about, and then that is it for the day. This says solving systems without unique solutions. So we're still finding what's the solution to the system of equations, but these are not going to come out to just be a single coordinate point. So let's start solving and see what we mean. Now, either one of these, I could solve using substitution or elimination. It doesn't tell me which one I have to use, so I could choose. Now, I notice that I have just a y here, so I could solve that for y, plug it into the other equation, and go with substitution. Or I could say, okay, no, I like elimination better, and I could look at this and say, oh, I've got a positive 2x here, and then I could turn this into a negative 2x by simply multiplying by 2. Therefore, we would multiply this equation by 2. I kind of personally like elimination better, but some people really like substitution better, and that's totally fine. So if I go with the elimination and I multiply everything by 2, this is going to give me negative 2x. Then I'm going to have positive 2y. And then I'm going to have 2 times negative 2 equals negative 4. Then I don't have to modify that second equation at all, because I have a negative 2x here, which will already cancel with this positive 2x. So I don't need to modify both equations this time, just one will do. And I don't want to have to do more work than is necessary. So I bring that second equation over just the way it is, didn't change a thing. Now, when I go to add these things together, well, I know that negative 2x and positive 2x, those cancel. It's a 0 pair, it's gone. We expected that, we planned it. However, when we look at the y's, I have a positive 2y and a negative 2y. That's another 0 pair. They cancel out and they're gone. So if everything on the left side canceled out, I have nothing left, so that means it is 0. Now, on the other side, I have negative 4 plus 0. Well, that's still negative 4. So anytime that all of your variables cancel out and all you have is a number equals a number, that means it's some kind of special case. It's either all real numbers or no solution. Or sorry, not all real numbers. Infinitely many solutions, IMS, or no solution. So what you want to look at is this statement that you have at the end. Your number equals a number. Decide if that is true or not. So does 0 equal negative 4? Absolutely not. This is false. So if it is false, that means that I have no solution. There is nothing that I can plug in to both of those equations that will make them come out true. So if you get a number equals a number and it is false, it doesn't really equal each other, then that means it is no solution. Now, let's look at number 8. Number 8 is going to be a little bit different, but a little bit the same. So, for this one, again, I could choose to use substitution. I could get that y by itself and then plug that into the other equation. Or I could do elimination because I've got a positive 12x here, which means I could turn this into a negative 12x very easily by multiplying by a negative 3. Or if you prefer, you could choose to get rid of the y's also. Either one would be fine. So if we go with the x's, then I'm going to multiply by negative 3 that gives me negative 12x. Then this gives me negative 3y equals negative 18. And then the second equation can just be brought over the way it is, because it's a positive 12x already, which will cancel with the negative 12x we just created. Therefore, everything else in that equation will stay the same as well. Now, when I go to combine, the 12's cancel. Good, we planned that. But, the y's cancel as well. So that means we have nothing on the left side. Then on the right side, we have a negative 18 plus 18. Those cancel as well, which means I have nothing on the right side. So if I have nothing on the left and I have nothing on the right, that's 0 equals 0, which that is true. 0 does definitely equal 0. So if that is a true statement, then that means we have infinitely many solutions. So these two cases don't come up that often, but they do occasionally come up. So we need to know that if we have all of our variables cancel and we get a number equals a number that is not true, it's no solution. If it is true, then it's IMS. All right, so that finishes up solving systems algebraically. Hope you